everyone. Welcome to Xiaohe Classroom. In this section, we will introduce the application of the high-speed pulse output function of M226CS. First, we need to open the hardware configuration. In the hardware configuration, we need to configure the axis. After clicking on the axis configuration wizard to enter, by double-clicking, we can add a pulse axis. The M226CS can add up to 10 pulse axes. I have added a pulse axis here. Let's actually look at the details of the axis. First of all, we can see that the axis number of the axis is 0. When we control the axis through the plukopen command in the program, we control it according to this axis number. Then the type of shaft can be selected as linear axis or rotary axis. The effective level of the motor direction can be set. The output delay time of the pulse direction can be set. And the pulse output point and the point of the directional output point can also be set. For example, choose Q1.0 as the pulse output point and Q1.1 as the directional output point here, and choose according to your actual situation. Then on the dimensional conversion interface, you can configure the dimensional conversion parameters of the shaft. Convert the number of pulses per revolution of the motor into the actual physical unit, such as the 10 mm movement of the screw corresponding to the motor to turn around, and then correspond to 10,000 pulses. If there is a gear reducer, enter the reduction ratio in the middle line. Then on the speed interface, you can set the maximum and minimum speed of the motor, the start and stop speed, and the maximum and minimum acceleration and deceleration speed. When in use, do not exceed the speed limit set here, nor exceed the maximum frequency of PLC pulse output 200. Then on the limit side, we can enable soft limit or hard limit. Then you can set the return to the original mode on the return to the original interface. Here, the return to the original function of the PLC is used. And then the No. 23 return to the original mode is selected. And the return to the original will be carried out according to the icon here. No. 23 mode uses the origin switch and positive limit. The origin switch signal is I0.1, and then the positive limit is I0.0. Then the speed of returning to the original is given through this side. After these settings are completed, then we can click End. After completion, we can use the plukopen command directly in the program to control. The library instructions are under the motion control library. You can select the enable of the axis. There are also instructions such as relative positioning, absolute positioning, speed control, jog, and return to the original in the read axis state. This program uses an enable, and then read the axis state command, absolute positioning, jog, and return to the original command. We directly download this program to see the actual operation. After the program runs, you can see that it has been enabled successfully, and it is currently in a standstill state. At this time, set the position and speed for it to perform absolute positioning movement. After the positioning is completed, the following operation will be performed to return to the original. Start returning to the original. You can see that it is now in the original state. Here the signal is artificially given, and the Q point has been associated with the corresponding I point by giving the Q point signal. It is equivalent to giving the I point signal. For example, give the origin switch a rising edge signal, and then it will reverse until it encounters the origin switch falling edge signal to complete the return to the original. After returning to the original, you can follow up with some other movements, such as jog movements. After triggering the jog, it will start running at the speed we give, and then it can also be reversed. In this way, we have realized the application of M226ES for axis control by pulse.